Hi engineering Janta, I am Vaibhav Shukla and today I welcome you all to the second part of Quicksort. Here we'll learn its code implementation and believe me, if you've watched the first video, Quicksort is going to be a cakewalk for you. Fine. So let's go ahead and dive in deep into this. This is the basic code of Quicksort or the recursive code of Quicksort. Here we do recursive calls to the Quicksort and automatically things get rolling for us. What I'm telling you is, you take an array. Let's take the array that we took earlier, 90, 15. So what I'm telling you is, this is 0, 1, 2, 3, 4, 5. These are the indices. Now, see carefully what's happening here. I pass this array, this whole array in this, fine, in this array. Now I pass 0 as the low, 5 as the high, and what I'll do is, if low is greater than high, which is 0 is lesser than 5, because if this condition is not true, then we are already ahead of the array, which is of no use or which makes no sense to us. So that's why we check this condition. After checking the base condition, what we do is, we create a variable index pi, fine, or pivot index. This is basically for that. What I'll do is partition the array in such a manner. This partition function is the magic function. This will behave in the same manner that we were doing earlier in the first part of this video. Okay, so partition is first particular magic function that I can say that's working here. So you pass the array, you pass the low, you pass the high. So I pass 0 here, I pass 5 here, I pass this array, this particular array, say let's say this is array, fine. So I pass this here. Now when I do this, what happens inside partition? Let's check what partition will do and what will come back here in return, fine. So here we come to partition. I have passed array, okay, array is written before, low is passed as 0, high is passed as 5, okay. Pivot, now we fix a pivot here, and that is nothing but array of high, which is array of 5, which was 45. Now what I'm saying is, let's draw the array again here so that things are easy for you. Now pivot is fixed here. This particular element is pivot now. I create a swap index pointer which is low minus 1. Low is 0. So swap index is minus 1 basically. This is where swap index pointer is. Okay. Remember something like that. Similar thing we were doing in the first part. We had said that this is swap pointer. Now I am saying it's swap index. Just the name is changed. The pointer is same. Fine. Now in this case, for int j is equal to low, there is an integer variable j which is set to low. Low is 0 in this case. Okay. Till j is lesser than equal to high minus 1, which basically means 5 minus 1, 4. So this condition is j less than equal to 4. So j will go till this place, which means it will traverse the leftover array except for the pivot, and j will keep on incrementing. Now if array of j, whatever the index j is, we'll put it in array, we'll check the value. So you can say that array of j is right now array of 0 because j is 0. If it is smaller than pivot, I told you if it is smaller, then something would execute. If it is not smaller, if it is like this, for example 90 is in this case array of j here, array of 0 equals to 90, which is smaller than 45. Is it true? No, it is false. So this if block won't execute. Now this if block doesn't execute, again the value of j increases. Now j is pointing here, okay, j is 1 now. As soon as j starts pointing here, these values change. I told you when the value is greater, eat 5 star, do nothing. When this particular value is when j becomes 1 now. Now j is 1 now, j is incremented. So when j is incremented, low becomes 1 because now j is 1 basically. So after the first execution, j is 1. Right now j is 1. Now in this case, array of 1 is 15, which is smaller than 45, so it is true, right? So first thing we do is increase the swap index. So swap index was -1, I increment it, and what I get is my swap index starts pointing out here. Okay, my swap index starts pointing out here. Now what I'll do, swap the value at swap index, okay, with what? Value at j. Basically what I'm trying to change is swap these two values, okay. Value pointed out by swap index should be interchanged with the value pointed by j. This we have done in the last video in the similar fashion, same implementation. Now when I change them, what happens? This array becomes, or rather let's change in the above array only, okay. 15 comes here, 90 comes here, okay. And after this, again j is incremented. So what will happen? J gets incremented again. Now j is pointing to 2. Now j becomes 2. For array of j is equal to 2, an array of index 2, what is the value? Value is 26. This is again smaller than 45. It is true. So again increment the swap index. What will happen? Swap index will start pointing here, right? This swap index will start pointing out at 90 again. Again you interchange them. Again you swap the element at swap index pointer, element pointed out by swap index, with the element pointed with j. Fine. So I interchange them. What happens? 26 comes here, 90 comes here. Same thing we have done in the last. So now you can understand the code implementation very well, and j gets incremented. So j is incremented here. Fine. And the value of swap index is now being pointed out here, okay. So now when I go further, j is again incremented. When I go further, I find that it is 95. It is 95. Basically what I'm saying is j has become 3 now. Fine. When j becomes 3, I come here, I check for the value at array at index 3, and what I find is it is 95. Is it true? No, this is not true. This is false. So this will not execute, okay. Now j is again incremented. J is again incremented, and j now becomes 4. So j starts pointing here. J becomes 4. Array of 4 is 20. Array at value in the array at index 4 is 20. This is smaller than 45. This is true. This executes. This if block executes. So swap index goes further. First of all, I increment swap index, and now I interchange the values. So what will happen after interchange? 20 comes here. This is 26. Okay, this is 26. 20 comes here. 90 comes here. Fine. And now if you carefully see, j has reached its limit. Now if I increase j, this loop will not work. So the execution of this loop has finished. What you will do now is you interchange, you swap again the values at swap index plus 1. Okay, basically you increase the swap index again, you increment it again. Okay, in this case what is happening, basically last time remember we had put it in correct place. Here one more thing is happening, your sorting is happening automatically. See what's happening. I incremented the swap index. Okay, now let's forget the j because the execution of loop has been completed, so let's forget the j. And if you correctly remember, my high was pointing out here, high was 5, right? So what I do is I interchange the value at array of high and the value at swap index plus 1. this is swap index plus 1 because this was my last swap index that I left. Okay, this was my last swap index that I had. So I push it to swap index plus 1 and change the values. So these two values would be changed. Here swap index plus 1 is being swapped with the value at array of high. So when I do this interchange, how it is going to look is this 45 and 90. So your pivot has reached its right place, and if, sorry, not 90, it's 95 here. So if you carefully see, this whole portion is sorted now. The right hand portion is sorted now, if you carefully see, right? You can still apply quick sort to it and it will be applied. I'll show you why I'm saying so, but pivot is now at its correct location. Fine. And now understand one thing. After this, what will be returned back to the function, because this has a return type int, so something is to be returned. So swap index plus 1 is something which would be returned. Swap index plus 1 was this value, because the last value of swap index, if you're watching this video, you can go back and see the last value of swap index was this, and swap index plus 1, swap index plus 1 is this value. Fine. So I return this value, which is 3. I return 3 here. So index pi is, this becomes equal to 3. Okay. What will happen now? I'll partition that into 2 halves and again apply quick sort. See how? Array again is passed, low is still 0, so I'll pass 0, and index pi, which is 3 minus 1. So here 2 would be passed, which basically means this portion would be passed because 2 is here. So this is passed to one quick sort, and then if you see, array is passed, index pi plus 1, which is 4, and high is 5. So this portion, this particular portion is passed to quick sort function again. Okay, and the same thing would happen again. You'll fix this particular portion as pivot, and then you'll see and keep on changing it. Once you keep on changing it and find its right place, you have it sorted. I'll show you how. See. Now let's assume we are implementing this portion's quick sort, and then you enter the partition function again, because that is a recursive call, so you'll again face partition. When the quick sort happens for this, what will happen? In this case, array is passed, low is 0 and high is 2. So this condition is verified. You enter the partition, low is 0, high is 2. See, low is 0, high is 2. Pivot is array of high. So now your new pivot for this particular partition, 15, 26 and 20. 20 is your pivot because this is high, 0, 1 and 2, this is high. I'll represent swap index with SI. Okay, so SI is at -1 as usual, because this is low -1, low is 0. So swap index here becomes 0 minus 1, which is -1. Now when you set j equals to low, which is 0, I set j as 0, and you check it here. See, j is pointing out here. For the first element itself, array of 0 is lesser than pivot, 15 is lesser than 20, this is true. 15 lesser than 20, this is true. So swap index is incremented. Now swap index is also pointing here. I increment it. I increment swap index, so it is pointing out at 0 only now. And now when I try swapping it, 15 would remain at its own place, no? So j gets incremented again. J gets incremented. J comes here. 26 is smaller than 20. No, it is not true. So this if block will not work. And what will happen is, now the loop execution has finished because we have reached high -1, which is 1. So let's finish this execution, let's forget j, and at array of swap index plus 1 at this place, swap index is 0, swap index plus 1, si plus 1 is this place. You replace that element, you swap that element with the element that is present at high, which is being pointed out by high. So I replace them, and if you carefully see, now my pivot is at its correct place. I return swap index plus 1 as the value, which is nothing but 1. So I return back 1 and nothing will happen, because next time you will find a sorted partition. So this portion is sorted, this portion is already sorted. If you subject this to quicksort, let's check what happens when you subject a sorted partition to quicksort. Okay, so what will happen? Again, everything would work in the similar fashion, and here low and high would change. So low would become 4, high would become 5. So in this case, pivot becomes 95, right? If you see, swap index is low minus 1, here swap index will become 4 minus 1, which is 3. So swap index is somewhere here for this, right, at 3, and 4 and 5 are the places where we are having our partition. Now in this case, j is equal to low, which is 4, so j is 4 now. Array of 4, I'll erase this 15 and 20 to avoid confusion. Array 4, which basically means value at index 4, is nothing but 90. Pivot is 95, because you had fixed array of high as pivot. 90 smaller than 95, true. What will happen? Swap index will increment. Swap index gets incremented here, si comes here. Now when swap index gets incremented, what you do is you perform swap function, array of swap index swapped with array of j. So now swap index is already pointing here, j was also pointing out here because j was low, which is 4. So 90 remains at its own place even after swapping. So once it happens, it has reached the end of the array, because j can only go till 4, high minus 1, 5 minus 1 was 4. This execution is completed. You give swap index plus 1, which is nothing but 5 as the final return to this function, and nothing will happen because this is already sorted. So now the partitions are sorted, and once you reach further, see, this partition is sorted as 15, 20, 26. 15, 20 and 26 is one sorted partition. After this, you were having your initial pivot at its correct place, and the right partition, which was 90, 95, is also correctly sorted. So this is the sorted output that you got here. See, fine. Once it is done, what's left in quicksort? Nothing is left. Itna hi hai quicksort. Quicksort is this easy. That is why I was telling you, watch the first video carefully. If you're somebody who has not watched the first video carefully, go and watch that video very, very carefully, because it is exactly the same implementation, just that I have put 90 and 95 in a different order there, which is not needed here. This code is a better optimized version of it. As simple as that. Okay. Now, in this case, quicksort has order of n log n as its best case and average case time complexity. Okay. So why is it so? Because you are partitioning, and every time you partition, the sorting becomes easy. But in the worst case, where you have something like this, 90, 89, 88, 87, 86, and you keep this as pivot, fine. So every time you'll have to push back. This is the worst case to sort, right? So in this worst case to sort, you'll have order of n square. Remember, whenever somebody asks you what is the time complexity of quicksort, big and bold letters, order of n log n. Always say this. This is the time complexity of quicksort. Don't go to the worst case time complexity unless explicitly asked. Fine, this is the time complexity of quicksort, order of n log n. Generally, that is why quicksort is considered better than bubble sort. better than insertion sort. That is why it is considered one of the best things to implement. Okay, so you can see this out, and worst case time complexity is order of n square. Now go ahead, dry run it and tell me what would have happened if you had fixed first element as the pivot. Go ahead, do its implementations and comment below those implementations. I'll check and verify. Don't worry. Fine. Whatever you have learned in this video, go ahead, spread it as much as you can. Tell to your juniors, your seniors, and the benefit of your comments would reflect here. If you stand a chance in top 3 comments, you get Prep Insta Prime subscription for free. And do not miss following us on these social media handles so that you never miss a hiring update. Okay. Whatever you've learned in this video, whatever good you felt that I taught you, go ahead, spread it to the masses, spread it to the people you feel need it. Keep on doing good without any expectation. Just keep doing good. It will come back to you. That's all. Thank you.